is Suvarchala, working as an associate professor in the Department of Computer Science and Engineering at IIR. In this session, I would like to discuss about the course description on outcome-based education, about COs, POs, and COPO mapping related to the course database management systems. This lecture includes what is NBA and what is outcome-based education system, outcome-based education system, as well as what are the various levels of assessing this outcome-based education system, and COPO mapping, what are the CSE department, vision and mission, BTech CSE department, PEOs and POs, and course overview, objectives and COs for database management system particularly, and key attributes for assessing the program, as well as various concepts of mapping of COs and POs and assessment of CO POs related to database management system will be discussed in this session. NBA, National Board of Accreditation, is an organization. It is responsible for the accreditation of higher education institutions in India. But NBA accreditates only courses but not the institutions actually. NBA is also full member of Washington Accord, and the NBA accreditates programs and but not institutions. So each program will get accredited by NBA if that respective program satisfies the criteria specified by the NBA based on outcome-based education system. What is outcome-based education? Institutions adopting OBE try to bring the changes to the curriculum by dynamically adopting the requirements of the different stakeholders. Like stakeholders who are the stakeholders of education system, students, parents, industry personnel, recruiters, etc. So OBE is related to the feedback system actually. That is, the outcomes are going to be assessed, and based upon that, again any changes are required in our syllabus. Those syllabus changes are going to be adopted by the respective committees. While doing this process, we will use this Bloom's Taxonomy. Bloom's Taxonomy is considered as a global language for education, and Bloom's Taxonomy is frequently used by teacher fraternity. Writing course outcomes, provides a ready-made structure and a list of action verbs, and also while assessing the students, these action verbs are used for generating the questions actually. So in this, various stages will be there. So initially, various levels of students, understanding concepts, memorization concepts related to that particular course will be considered. The stages are going to be assigned in complexity and what they demand of the students. First, initially, students simply remember the information provided to them. Then reciting some does not demonstrate. And after that, they'll understand, demonstrate, and explain certain ideas. And students are then give some challenges, that they are challenged to apply this information, to use it in new ways, and deeper understanding of the previously covered material, etc. After applying, additional some more levels are there where your student is able to implement certain their independent ideas actually. So these 6 levels are there. Remember, understand, apply, analyze, evaluate, and create. And remember, understand, apply, up to analyze can be considered while assessing our student, whatever the student acquired, student skills by using through some direct assessment, that is through examinations, SE, CIE, etc. And coming to this analyze, evaluate, create, these 3 higher levels are going to be assessed about students acquiring this knowledge and everything, analyzing and evaluating and creating new products, etc. Based upon their projects, mini projects, course projects, final project and FSA projects, etc. And these, to assess them, these are the various verbs are used while giving while getting the assessing the students' acquaintance actually. These OBE 4 levels of outcomes are going to be considered in from OBE: program educational objectives, program outcomes, program specific outcomes, course outcomes. These program educational objectives are promised by the department to the aspiring students about that they will achieve once they join the program actually. Generally, these POs are going to be about the professional and career achievements after 4 or 5 years of graduation. That is, after completion of the graduation, these program educational objectives assessment is going to be considered. So, POs can be written from different perspectives like career, technical competency, behavior, and so on and so forth, which can be assessed based upon students' feedback after graduation. So 4 or 5 POs are generally recommended for each course, that is computer science, BTech computer science, etc. Various courses. Program outcomes. This program learning outcome is broad in scope and it is able to do the end of the program, each program. So PO's assessment is going to be done at the end of the program. POs are to be aligned with the graduate attributes which are given by the specified by the Washington Accord, and POs are to be specific, measurable, and achievable. So after completion of the program, PO assessment is going to be considered. So based upon the student's performance after completion of the during this process, as well as after completion, what have they achieved based upon the students' achievements, these program learning outcomes are going to be assessed. NBA has defined 12 POs and we need not define these POs, but we will use some of the POs, relevant POs for each course to assess that respective course actually. Some of them are going to be common for all the institutions. These 12 POs are common for all institutions in India. Program specific outcomes. The term itself specific indicates program specific outcomes are statements that describe what the graduates of the specific program is specifically related to CSE students, specifically IT students, specifically ECE students. For a specific program students, what in the engineering area, what they should able to do after completion of their course. These are going to be assessed based upon the achievements of the students in the respective programs. So a list of PSOs written for Department of Computer Science and Engineering are given below, which are already published in our website also. So understand, design and analyze computer program in the areas of related algorithms, system software, web design, machine learning and network, and focus on improving the software reliability, network security and information retrieval system. Make use of modern computer tools, creating innovative career paths to be in an entrepreneur and desire of higher studies. So these PSOs are related to computer science. Similarly, PSOs are going to be defined for each program by respective committee people actually. A committee includes HODs and faculty and dean, OBE, etc. Now coming to the course outcome. So these course outcomes are specific to each course. Each course means here each subject in other words. So now we have been discussing in previous lectures database management system. So we'll discuss the course outcomes, what are the POs are relevant POs for the database management system course, and how the mapping and assessment process is going to be carried out. Before that, we'll discuss what is a course outcome actually. So a course outcome is a formal statement of what students are expected to learn in a course. What they will learn during that course, after completion of the course, these are the things they'll achieve actually. When creating a course outcome, we have to remember that outcomes should clearly state the student will do or produce to determine or demonstrate what they learn actually. These course learning outcome statements refer to specific knowledge related to the course now. In that course also related to some specific topic or area, knowledge acquired, practical skills acquired, areas of professional development, their attitude, higher order thinking skills, all these things are going to be specified through these course learning outcomes. That is the faculty members what they are expecting from students to develop, learn or a master during this course. Those are going to be represented by these course outcomes. Course outcome statements on the course level describe what the faculty members want students to know at the end of the course. At the end of the course. For example, we are considering this database management system. So after completion of this database management system, what about students know and how we are going to assess the students acquire such type of skills also. What faculty members want students to be able to do at the end of the course, those are going to be specified through these course outcomes. Generally, these course outcomes will have three parts. That is, they will specify by the students what they are observable and how, what are the actions to be considered by what are the students acquired, how those are going to be measurable, and these outcomes specify an action that done by the students rather than faculty member. So these course outcomes are what students will acquire after completion of this course. So those are going to be specified through these course outcomes actually. And relationship of the course outcomes to program outcomes. And through these course outcomes, these must be in line with the program outcomes also. So there must be some mapping with these course outcomes, program outcomes. So once these course outcomes are achieved, after assessment of course outcomes, internally they must again related to the program outcomes to be achieved actually. That means course outcomes are during the course, program outcomes at the end of the course. Combining all these achievements of the course outcomes, the programming outcomes, assessment and achievement can be analyzed by us. So for that purpose, we need how these course outcomes are going to be mapped with the program outcomes. So the course outcomes need to link with the program outcomes. Use these various techniques can be used, and this is the following technique which generally we will use for linking process. Students should be able to do, we will write, and behavior resulting evidence. These must be linked. Based upon this, the linking of course outcome with some programming, not all, depending upon the course outcome, it may be linking with some one or more program outcomes. So for example, we can use the following template to write an appropriate course level learning outcomes. On completion of this course, students will be able to something, a knowledge or a concept or a rule or a skill, etc. By we are going to assess how they will demonstrate this knowledge and how it can be assessed, that will be represented. So that means these POs and COs must be mapped with some or more POs actually, one or more POs. To do this, course articulation matrix mapping can be used. This course articulation matrix shows the educational relationship, that is level of learning, how far it was achieved. Systematically, it will be explained. So level of learning achieved between course outcomes and program outcomes of the course. So this matrix strongly indicates whether the students are able to achieve the course learning outcomes. In turn, because of this achievement of the course learning outcomes, what are the program outcomes are going to be achieved, up to what extent? That can be easily evaluated. So that matrix can be used for any course and is good way to evaluate the course syllabus by following certain set of rules actually. That is, at the end, the POs can be calculated using various descriptors, and we will define based upon how the assessment is going to be done. And mapping of CO towards PO is evaluated using various descriptors such as a high, low. That is, what is the intensity of mapping actually. And now these are the introduction about this outcome-based education, why we are using and what is the purpose of course outcomes, their assessment for each course. Now we will move to the assessment of the database management system course. What are the COs are defined, what are the objectives of the course, etc. Before that, I would like to display the vision and mission of Department of CSE, because this database management system we main objective is related to as a course, classic course related to computer science actually. So the vision of the Department of Computer Science is these things. And for BTech CSC, the program educational objectives are displayed. That is the graduate of a computer science and engineering program. 4 POs are described. Remember, this PO assessment is not going to be done immediately. After completion of 4-5 batches only, this PO assessment is going to be done. Because these PO assessments are broad achievements after completion of this course, how the students are established in their career will be properly assessed through these PEOs. So 4 PEOs are defined and finalized for this BTech CSC, specifically BTech CSC course 8IA. And this program specific course for BTech CSC are also 3 PSOs are there. So relevantly, we will choose which of them is relevant to our course, respective course. And the mapping has to be done, no, POs and COs. While doing this mapping, first we are supposed to understand what are the POs and what are the various important features are there in each PO. And this type of table was there for all POs. But I'll discuss only 4 POs because these 4 POs are mapped to my course. Database Management System course was mapped to PO1, PO2, PO3, PO4. So that's why I'll discuss only these 4 POs and what are the various important features or assessing features are there in each PO. First PO is there. First PO is related to the engineering knowledge, application of this engineering knowledge, base knowledge, that is base sciences, mathematics, science, engineering fundamentals, specialization of solutions of the complex engineering problem. So whichever the course outcome is related to this base knowledge, understanding of basic knowledge related to mathematics or science, etc., there the respective outcomes are mapped with POs, PO1. So what are the key areas, vital features which can be mapped based upon the important features are knowledge, understanding, application of scientific principles and methodology, mathematical principles, and one or other engineering disciplines to integrate, support, study their own engineering. So 3. So these 3 features are there. So how many features of this PO1 is mapping with the any other CO1 based upon that CO mapping number of mapping features can be identified. Similarly, for PO2, totally 10 features are there. Based upon the PO2 statement, these are the vital features are identified. For PO3, these are the 10 features are identified. For PO4 also, 11 features are identified. So that means here PO1 is basic problem analysis, problem knowledge, engineering knowledge. PO2 is related to the problem analysis, that is identification of the problem, etc. And PO3 is related to design and development of the solutions for any problem. Then PO4 is related to investigations on complex problems. So related to database management system specific syllabus, these 4 POs are relevant to this course. We will map whatever the COs are defined for that particular course, those COs are mapped to these POs actually. While mapping, these vital features are going to be used. Whatever the features are there, these features are going to be considered. How many number of features are mapping, based upon that we will assess the strength of the mapping actually. So we'll come to our key area, that is database management system of IARE. It consists of 5 modules. I'll discuss about the syllabus which at the end of this session, and already about all these 5 modules the lecture sessions are going to be conducted actually. Now the course overview. Database management system is intended to provide a clear understanding of fundamentals with emphasis on their applications to create and manage the data sets, and also it emphasizes the technical overview of database management system softwares, and it includes, these are the syllabus, about the basic principles of database management system, and normalization, that is logical design of the database management system, physical design of the database management system, as well as databases, concurrent transaction processing, security, recovery, file organization techniques, and storage devices also. This will provide adequate knowledge to understand future evolutions of the data technologies. And for this course, prerequisite, those who would like to handle of this course, they're supposed to complete or clear the courses. They must undergo programming for problem solving as well as the data structures. These two courses must be completed or must be clear before opting this database management system. And marks distribution, that is for assessment, the direct assessment, SEE, CAE, two kinds of examinations are conducted, semester end examination as well as continuous internal assessment. These two are there. This internal assessment regularly will be done by through some examinations and technical talks as well as quiz or sometimes videos also. And semester end examination will be conducted at the end of the semester as a written examination. It will be conducted. So total 100 marks will be considered for this course, and the student objectives of the course are: these student will try to learn and they will acquire the analytical thinking and identify the efficient ways of designing database by encapsulating the data requirements for business and organization scenarios. The develop expertise, students will develop expertise in database languages, SQL, to develop the sophisticated queries, extract information from large data sets while implementing the real-time applications. And also this course enhance the skills to develop and manage the data in solving related engineering problems. The problems which are related to various areas, various programs are related to this data management is there actually. In almost all engineering areas, data management concepts are there. Data management requirement is there. So the data storage and manage and retrieve, everything can be done easily, purposefully, practically, if this course completes properly by the student effectively. So this database management system course consists of designed 18 COs are designed for depending upon the topics included in their academic syllabus. So after successful completion of the course, students will able to do all these outcomes. They'll achieve all these outcomes actually. While doing this, while writing this course outcomes, we also assessed what is the respective knowledge level of Bloom's taxonomy student will acquire actually. So CO1, the first four are related to, first three are related to, four are related to the first module, that is basic database management system concepts, principles, as well as how to design a conceptual data model also. Conceptual data model means how to construct an ER model for any given application or for any given problem statement. So the first one, define database, characteristics, function, database management system, and types of users to describe the large sets of data. So defining these things, no remembrance. And the second CO is comparing with the traditional file management system. Why we are moving towards data management system? That is going to be understood by the student actually. So that's why its level is understand. And the third course outcome is related to the various data models, instances. All these are basic definitions or basic principles of database. So how these are going to be useful to us while designing our database. So it's remembrance. And CO4 is modeling any real world database system using first ER model. So any application is given, we will develop a conceptual model through this ER model by drawing ER diagrams. That means we are applying this ER model basics to solve any real world problem. So that's why the knowledge level is applied. And 5, 6, 7 are related to relational basic relational approach. So that's why 5 is defining the basic relational model and basics of fundamentals or building blocks of relational database management system, that is relational model. What is relation, etc. will be. So that means they are going to, those are fundamentals they must remember. So that is remember. And next CO6 is define the concept of relational algebra. That is how this relational algebra, relational calculus, pure languages are going to be used to access our data. And in construction of queries or developing the queries to retrieve the data from our relational database by using some mathematical concepts of relational algebra, relational calculus. That means we will apply this relational algebra, relational calculus basic fundamentals to get the answers, or to get the retrieve the information from our database through some relational algebraic queries. So that's why the knowledge level is applied. Then we'll use demonstrate SQL use of next 3, 8, 9, 10, 11. These are all related to module 3. So these are related to SQL queries as well as normalization process. Basically, uh, first we will understand what is SQL and what are the structures of SQL, etc. And then we will apply these concepts based the concepts of SQL to write any SQL statement to retrieve information according to our requirement actually. So that's why understand and apply are there, two COs. Similarly, we would like to design our, now up to now we designed only conceptual model. Now logical model we will design. That means we'll convert ER model into relational model and normalization is applied. To do this process, we need to learn normalization process. Student need to learn normalization process first. So that's why student will understand what is functional dependencies, inference rule and minimal, etc. And student will apply these rules, normalization rules to the database real-time application to reduce the redundancy of the respective database while implementation. Students next 4, that is 12, 13, 14 are related to the module 4, that is transaction management as well as the data storage. And in this, student will learn what is a transaction, what are the asset properties, and how data manipulation is carried out by concurrent transaction, how those are manageable. These are learned by the student, and they'll learn, student will try to apply to preserve database in a consistent state these concurrency techniques, as well as any failure occurs, how to apply these recovery techniques also. And the last 4 are related to for the last 3 are related to our query processing as well as data storage, how the data was stored internally at physical level, that is physical design you can say. To learn these things, students supposed to understand the physical devices structure. So that's why disk storage devices, file organizations, etc. are learned by the students and they'll remember. It is at remember level. Then student will apply these indexing techniques to effective retrieval of information while implementing the database physically. So it is apply level. Similarly, student will learn various indexing techniques, tree indexing techniques, hash indexing techniques, etc. So that they can students can apply while solving the representation of data internally, so that efficient retrieval can be carried out actually. Then full size real-time database system for any industry or business scenario can be done by the students by applying all these things, whatever they learned during this course, and the student able to design a database, implement a database of for any organization as per the need of the client actually. So these are all the outcomes. So the course knowledge competency levels are remembrance, understand, apply, analyze. So up whatever they learn, understand, those are going to be applied. How these mappings are going to be done? Strength, what is the strength? How program outcomes are going to be assessed? These are the 4 outcomes considered by us and which are relevant to our the course which we discussed just now, database management system. It is having the applying the knowledge, basic knowledge of mathematics and sciences, as well as the data structures which are already engineering based, engineering programming language are applied, and problem analysis, because any application is given, database application, it will be analyzed and database is going to be designed. That's why investigations of complex problems is also applicable, because it consists of analysis. The data was given, it must be interpreted first, and it must be synthesized, analyzed, and it will be stored, in which format it's supposed to be stored. And to do all this process, any new tools must be used by the expertization in the tool must be achieved by the student. So that's why PO4. So PO1, PO2, PO3, PO4 are relevant to this course, and the strength of PO1 program outcome 1 is 2, and the strength is 3 for the conduction of investigations on complex problem as modern tool usage. These 2 are having high strength. We'll assess that further. And 1 PSO is mapped to this course, and program specific outcome relevant to this course is focus on improving the software reliability, network security, or information retrieval system. Here we are using retrieving the system. And strength is 2, because the proficiency is going to be assessed by industry exposure and the AAT. And first 4 POs are going to be assessed by CIE, continuous internal assessment, examination, quiz, AAT, and videos also. So this is the mapping we are going to do actually. So each CO we will first read, and based upon the CO, to which PO it is going to be mapped, that will be assessed first. Whether it is mapped, tick mark indicates the respective PO. First 4 POs are there, no? So first PO is engineering knowledge. What is first CO? Define database characteristics, function, database management system, types of the users, describe large sets of data. Basically, database management system itself is based upon the set theoretical concept. So mathematical approach is going to be identified. So that's why, and as well as we are using some data while storing the data structures are also used. So that's why we are applying the knowledge of mathematics as well as engineering. So that's why PO1 is mapped. So we'll take some other thing, CO4. Let us assume that we'll take CO4. What is CO4? So CO4 is related to model the real world database system using entity relationship diagram from requirement specification. So requirement specification are there, and we have to create a model. The entity relationship model must be generated. For that purpose, first we have to, real-time application or real-time problem is given. It has to be analyzed, and we have to conduct of investigation, because this is a real-time application was given. It has to be analyzed first. Then identify the entities, relationships, etc. And the logic, what are the relationships among the entities must be analyzed by us, and how the data must be stored. For all these things, this conducting investigation complex problems, PO3 is going to be relevant, as well as PO4. Why PO4? Because we are using a tool, drawing ER modeling is a tool actually to model our database. Conceptual modeling is going to be done through this entity relationship model. So a tool is used to draw these diagrams. Also modern tools are going to be used by us. So that's why 2, 3, 4 are going to be relevant with this 4. So CO4 is mapped with 2, 3, 4. That means we will read this CO and we will analyze this CO, and this CO is going to be mapped with the relevant PO depending upon the understanding of the perspective. We'll do one more thing. CO14 is there. So what is CO14? CO14 here illustrate the problems of data management in concurrent environment by using recovery technique to recover the lost data. To do this process, some mathematical approaches are required, in the recovery techniques we are using, and so we are considering this one, and any problem, any failure occurs database management during the concurrent transaction, whatever may be the type of the failure, maybe system failure or a transaction failure, how those are going to be recovered by using some mathematical concepts, some techniques were introduced actually. Similarly, and what type of failure is there, how to retrieve, loss information can be get back. These are going to be analyzed. This is a problem, so which is going to be analyzed through various techniques, and how to retrieve whatever the transactions are not completed actually because of those failures. That means to maintain our database in a consistent state, how the transaction management, concurrent transaction management can be implemented. Similarly, to implement these things, we need some implementations related to some mathematical approach, whatever the analysis we have done based upon that, by using data and some procedures, we will implement them. So PO4, 1, 2, 3, 4 are mapped. Similarly, PSO also, because the security, network security, etc. security is related to that. Here, to maintain security only, we are going to consider. So we have to, each CO must be properly analyzed, and what type of PO is, or which PO is mapping that. First, we will done this mapping of each CO with POs as well as PSOs. After mapping, what we supposed to do, what is the strength of the mapping has to be analyzed by us. The strength of the mapping is going to be considered depending upon this number of key competencies. Key competencies means I explained you. Each PO will have some set of key competencies. PO1 is having some 4, PO2 is 10, 3, 10, 11, 4 is 11 competencies, etc. Once we have a mapping between CO and PO, based upon the statements of the CO and PO, what are the competence levels, or what are the types of competence levels are going to be mapping them. Coming to the first one, CO1, PO1, the competence define database, characters, functions, and database management system. It's a sets of data. These are going to be done with the knowledge of mathematics, with the knowledge of, as I explained you, set theoretical, etc. Some mathematical concepts are required. Engineering fundamentals, that is minimum programming, as well as data structures are required. So we are using these two, that is knowledge of mathematics and engineering fundamentals. Two key competencies are there actually, mapping here. So that's why strength is going to be 2. That means how many number of vital features are mapping with our CO. Depending upon that, we are writing here the number of key competencies. Coming to the CO2, CO2 is mapped with PO1, PO2. PO1 means here, compare traditional file processing system and database system for constructing a database using knowledge of, that means this is the CO for us. We will do this by the knowledge of mathematics, science, and engineering fundamentals, as well as to compare them, as well as to create, and we need to analyze them first. So that's why the problem statement and definition, we will consider these 2 terms are mapping. So with PO1, 3 terms, and with PO2, 2 terms, because while comparing, we need to analyze them. That means the problem statement must be considered, system definition, as well as the formulation, as well as abstraction. So 2 key competencies are mapping with our CO2. So 2. Like that, we have to map each CO with respective PO based upon the number of vital features which we discussed earlier. So I discussed for 4 only, because 4 POs we are considering, but for each PO such type of key competencies, vital features of key competencies can be easily identifiable by us. Once you know, there is a justification is there for us, this mapping. These are the terms internally we are analyzing, and mapping is there. That's why the strength is also assessed by us, number of key competencies. So this is the matrix is used, justification. Because of this scientific justification, mathematical justification is going to be considered for this mapping. Just like that, no, it's not based upon our intuition, based upon some proof is there. This is the justification. After having this such type of number of competencies, I'll put all these number of competencies in a map here. So CO1 to all 16, and I didn't put all, but 18 COs are there. So for 18 COs, you observe here. In the first column, PO numbers and PSO numbers, first row. In the second row, please observe here, this is a POs and PO numbers, and you observe here. Second one is number of vital features of the respective PO. How many maximum features are there? For PO1, 3, PO2, 10, PO3, 10, PO4, 11. These four I explained you already. So like that, for all POs were already defined. POs and PSOs, what are the maximum number of vital features are there. So among these vital features, how many vital features are mapping with our COs, we will write. Because we already mapped now here. So these numbers we are going to write based upon here. So CO1 is having, let us assume that we are having CO1 is 2. CO2 is with PO1 3, 2. So you observe. And we are going to have CO3, 2, 4 and so on and so forth. Once you have this number of matches, we can find out the percentage. Percentage means here, out of 3 features, 2 features are mapped. That means how much? 66.6%. Out of 2 features, out of 10 features, 4 features are mapped. So out of 10, 4 features are mapped means 100 we have to consider. So we get 40%. Like that we will calculate percentage. Out of 11, 3 features are mapped. Up to for 11, 3 features. For 100, how many? So it may be some 22 point something will be there, 28 point something. That means the percentage is going to be calculated depending upon total number of features, how many features are mapped. Based upon that, the percentage of mapping of strength can be easily identified. You observe 66 here, 66 and 40. Here 2 features and 4. 2 and 4 again same. 4, 4, 3. So 4, 4, 3 means 40, 40. 3 means 11 no. So 27.7 is there. Like that we will find the percentage of key competencies for COPO mapping. So 3 tables we decided. We designed. First table is which CO is mapping with which POs. Only number of the PO which is mapped was given. In the second table, we identified which POs are mapping with its respective COs are mapping with POs. How many number of key competencies are mapped. Then in the third table, we have summarized the number of competencies of each PO mapped with respective COs are going to be identified. Now in this table, we are finding the strength based upon the percentage of mapping. That's it. That is percentage of key competencies mapping between CO and PO. Previously, number of vital features. Here, percentage. This percentage is calculated based upon the highest number of vital features available to the respective. Once you identified this percentage, based upon the percentage, CO, PO and COs and PSOs on the scale of 3 we are considering. 0 is going to be considered as no correlation, 0 to 5%. And 2 we are going to consider as a 40 to 60% is moderate, competency level is 2. And 1 to 5 is low, right? So we are going to consider competency level is, we are going to consider low to slight. And 3 is going to be considered as a 60 to more than 60, substantially high. So no correlation, low correlation, moderate and substantially high or high. 0 means no correlation, 1 means low, 2 moderate, 3 substantially high. So instead of putting this 0, 1, 2, 3 directly, we are mathematically we are properly mapping and we are getting all these values actually. So that means if COPO on the scale 0 is means if the percentage is between 0, 5, 0. Percentage is between 5 and 40, previously we calculated no percentage, so 1. 40 to 60, 2. 60 to 100, 3. So based upon these percentages, the respective concepts are going to be considered. So according to that, you observe 60 means 3, 40 means 2, etc. We will get the course articulation matrix, that is CO, PO and PSO mapping is, this is the strength. So CO1 strength is 3 for mapping of with PO1, CO2 is with PO1 3, PO2 1 and so on. So these values are acquired by using respective mathematical formulas actually. So like that we calculated, we found the articulation matrix, and based upon this mapping, the assessment is going to be carried out. So if CO1 is assessed, based upon the CO1 assessment, the respective PO, some ratio of assessing the PO can be easily considered by us. So while doing to do this all these assessments, some assessment methodologies must be adopted by us. So in this course, the assessment methodologies direct and indirect. Direct methodologies are CA examinations, SE examinations, assignments, seminars, and tech talk is there. These are all L. 5 minutes videos are there. These are some of the techniques used, methodologies used to assess the achievement of these COs and POs. Achieved based upon the assessment of the students, the achievement of these POs can be, COs can be done by us. And indirect methodologies are there. So early semester feedback, end semester OBE feedback, and these two are used as an indirect methodology. So this course consists of these 5 modules: conceptual modeling, relational approach, and SQL query, basics, relational database management system, normalization SQL, transaction management. The first module includes basics of the database management system, and also while designing the database, the first step, that is conceptual modeling. Requirement analysis, conceptual modeling is going to be done. In the second module, we will convert into logical model. So relational model is going to be generated. A logical model is going to be converted. The conceptual model is appropriately converted into relational model actually. And also how to retrieve information by using some relational pure languages can be discussed, will be discussed in the module 2. In the module 3, to implement, how to implement this relational model which we designed, no? It is implementation. To implement what we need to learn, that means what the students are supposed to learn. So SQL was introduced as a commercial database management system language. So that's why through SQL, how the database is going to be implemented, created, all how to access the data, retrieve the data from the database. These will be discussed in this third module. Before this, SQL logical design was done partially previously. That refined logical design is going to be considered through normalization process. To learn this normalization process, students are supposed to learn what are the dependencies, key values, etc. What are the keys in relational databases, various dependencies, various constraints were discussed in this module. In the fourth module, once student aware of about what happens internally and how to create, and students supposed to learn internally how the simultaneous accessing of the database can be considered through this transaction management, concurrent transactions, how those are executed, simultaneously how the transactions are executed, what are the problems with such type of simultaneous accessibility, how such problems are solved, if any failure occurs, what happens, how the recovery will be considered, what are the various techniques are available to manage transactions properly, concurrently, will be discussed in the fourth module. In the fifth module, physical design, related to physical design, the logical design as well as implementation were covered in the previous 4 modules. Now, what are the various techniques are there to store our database at the low level, that is physically in the secondary storage devices. and how it can be stored so that our information retrieval process is more effective, and introduced the basic concepts of or basic steps of query processing. So this is the syllabus included in this course, and based upon the syllabus, the COs were uh, defined, and mapping process was analyzed by us. Thanks for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.